Hello everyone, welcome to my channel. Today I will explain about Bode Plot and how to use AI to generate it. First, let's see an example. Here is a vehicle. Take it as a system. The input of this system is steer, angle, delta. The output of the system is vehicle's yaw rate, R. Now, how can we understand the style of this vehicle? Is it sporty or comfortable? The Bode plot consists of two charts. The horizontal axis of the Bode plot is frequency, F, Hertz. The top of the chart is gain. The unit is dB. The second chart is phase. The unit is degree. In this example, we want to know the ratio of the output R to the input steer. We call it yaw rate gain. Usually, this curve looks like this. This is the gain curve. And here is the phase curve. This is 0. Let's explain about the curves. In the low frequency here, in this range, the low frequency means the steering wheel is turned very slowly. In this range, the yaw rate gain remains constant, which means this is steady state. Steady state. And in a specific frequency here, the yaw rate gain reaches at a peak value. This is called resonance frequency. The higher of the resonance frequency, the more sporty the vehicle. And the gap between the steady state to the resonance peak value, this gap represents the damping performance of the vehicle. The large gap means the vehicle's damping performance is bad. And in the high frequency here, high frequency means the steering wheel is turned very quickly. The vehicle cannot follow the steer. The yaw rate gain decreases. Next, let's see the phase plot. In the low frequency, there is no lag between yaw rate and steer angle. No lag. And in the high frequency, the lag between yaw rate and steer angle is much bigger. Let's summarize the purpose of Bode plot. First, the gain plot tells us the ability to amplify or attenuate the output relative to the input. And the phase plot tells us whether the output leads or lag the input. I will use an example to explain how to generate Bode plot by AI. This is sprung mass M2, and this is suspension stiffness Ks, and this is suspension damping Cs, and this is unsprung mass M1, and here is tire stiffness Kt, and this is the road disturbance, road displacement Z0, and this is unsprung displacement Z1, and this is sprung mass displacement Z2. This is a quad car suspension mode. Now, let's build the equations. For the sprung mass M2 times Z2 double dot. This is the sprung mass acceleration Z2 double dot equals Ks times Z1 minus Z2 and plus Cs times Z1 dot minus Z2 dot. And next, for the unsprung mass, M1 times Z1 double dot equals Ks times Z2 minus Z1 plus Cs times Z2 dot minus Z1 dot plus tire stiffness Kt times Z0 minus Z1. Now we have these equations of this mode. In the past, we usually use these equations and transform them into state space or transfer function, and then we can generate Bode plot. But now we have AI. We will use AI to generate Python code or MATLAB. Then we can generate this Bode plot. Here is the prompt to AI. First is parameters. You can use your parameters to exchange it. Second is equations that we built just now. And finally, this is the prompt to AI. Please generate Z2, the sprung mass displacement, over Z1, the road disturbance, Bode plot, Python code. I will input this prompt to Gemini. And the Gemini will generate Python code. And I can use it to build the Bode plot. Let's see the result. This is the result of Bode plot. The first peak represents the sprung mass resonance frequency. Sprung mass. And the second peak represents the unsprung mass resonance frequency. Almost all vehicles will exhibit these two resonance peaks. On the phase plot, there is a 90-degree phase shift near the two resonance points. From this graph, we can clearly see the characteristics of this 2 degree of freedom quad car suspension model. This is the Bode plot generated by the AI. One last point. While AI can generate code quickly and accurately, the understanding of abstract models and the interpretation of the results are still up to us. AI definitely cannot help you implement something that you don't understand. I'm Kevin. See you next time.